Hi everyone, I'm Nadziim. Today I'll be talking about my research poster on Carbapenems. So, Carbapenems are a powerful class of beta-lactam antibiotics, and they are often used as the last resort when doctors are dealing with multi-drug resistant infections and the things or bacteria that other medicines cannot handle. So to start, looking at the origin, these were originally derived from a bacterium called Streptomyces cattleya. So we have a semi-synthetic versions like imipenem and a fully synthetic ones like meropenem, which were developed to be even more effective against staph bacteria. And if you check out the structure section, what makes them unique is their core nucleus. So carbapenems have a beta-lactam ring fused to a sulfur-free 5-member ring. So this design, along with a specific trans-hydroxyethyl side chain, makes them incredibly stable and resistant to being broken down by most bacterial enzymes. So in later generations, we even added a C1 methyl group just to protect the drug from being degraded by our own renal enzymes. So our main question is, how do they kill these bacteria? So their mode of action is all about disrupting the cell wall. They penetrate the bacteria and bind to penicillin binding proteins or PBPs. So this stops the bacteria from cross-linking their cell wall, leading to bactericidal lysis. So basically, the cell wall fails and the bacteria burst. And one more cool feature is that the carbapenems have a post-antibiotic effect, or PAE, where the drug continues to suppress bacterial growth even after dosage levels in the body have dropped. However, some of the bacteria actually have developed a sophisticated resistance mechanism to survive against carbapenem. And some of them are actually MRSA, multi-drug resistant Staphylococcus aureus, and CRE, which is the carbapenem resistant Enterobacterales. So I'll be talking about the resistant mechanisms. So there are 3 that I can highlight here. So the first one is carbapenemases. So this is the most significant threat because it allows the bacteria to produce a specialized enzymes like KPC or NDM1. So these enzymes act like a molecular scissors. They specifically target and hydrolyze the carbapenem ring, deactivating the medicine before it even reaches its target. So next up is porine loss and mutations. So to work, the drug must enter the bacteria through tiny channels called porins. So some gram-negative bacteria like Pseudomonas can actually mutate or turn off these channels, effectively slamming the door shut so the antibiotic cannot get inside. And last but not least is the efflux pump. Even if the drug gets inside, some bacteria have overexpressed efflux pumps. So these are active transport proteins that recognize the antibiotic and physically pump it back out of the cell. So this keeps the internal concentration low so that the drug cannot be effective. Finally, regarding the cost, carbapenems are actually very expensive due to their complex, multi-step chemical synthesis and low production volume. So we tend to lessen the exposure of carbapenems towards most bacteria since it can build up resistance towards it and make it less effective in the future. And if you are interested in looking at my sources, you can scan the QR code below. And that is all from me. Thank you.